All right, you see the slide?
Yes, thank you.
All right, thanks everybody for having me, and happy Friday afternoon. As Monty Python would say, now for something completely different, I think.
So large.
I'm from, as I said, from SOX. The role I play is the research director within the organization, and I'll tell you a little bit about. So I'm here today to tell you everybody a little bit about SOX and the role we play as a regional from a networking perspective, but also some of the research activities we're involved in, and just sort of hopefully to give an example of the role we play and the types of things we do, and basically to say, relative to the South Big Data Hub, you know, we're here to play that supportive role on all sorts of different projects, and to do what we can to make those successful for the region. So, just as a sort of background on what is SOX, the name and the history can be a little confusing for folks in the association. So basically, we're a regional network operator for primarily serving the Southeast U.S., the R&E community. We date back to the roots date back to NSFNet and SURNet days of the late 80s. Today, we operate as a separate 501c3 organization. So people ask, so there's these three terms, right? SOX, Southern Light Rail, and Georgia Tech. So let me try to demystify that. The name we all go by is SOX. That's the sort of the name we're most known by, and what we generally use. SLR, or Southern Light Rail, is the 501c3 organization under which SOX operates as a project. You know, back in the NLR, National Land to Rail days, you know, SLR, there was, you know, was perhaps likely to be the common name, but no longer, and the SOX name is both older and has is more widely known, and that's what we use. We are affiliated with Georgia Tech as an organization. Basically, what that means is there's a research contract from SOX. SOX is a separate company with a board that's independent of Georgia Tech, but SOX has very few staff, if any, most of the time. The project itself is operated as a contract with Georgia Tech. So, for instance, myself, Cass D'Angelo, the SOX executive director, we're all employees of Georgia Tech, and with day jobs, as we often say. You know, we do many other things, but part of our time and part of our obviously part of our effort is spent on the SOX project. Focus is on connectivity. We're a regional network, Internet 2, ESNet, and commodity services. 21 members, including universities, state net research networks, and national labs, and active member of the QUILT. For those not familiar with it, the QUILT is, most regionals are part of the QUILT, and the QUILT exists primarily as one of the main goals is to basically amortize and combine the buying power, if you will, of the networking R&E networking community to negotiate better terms with the providers. And Cass, who is our executive director, is a member of the executive board for the QUILT as well. So here's the answer of why is Russ here today. The SOX footprint looks a lot like the South Big Data Hub footprint, and of course, with connectivity and support to institutions throughout, And even if you're not on this map, there's a good chance that we're collaborating with you, or have a way to connect through and collaborate with folks, or that or better state, that someone we support at one of these institutions is collaborating with you, and so we're part of that story and part of that support chain. Over the last year, one of the big efforts of the in the R&E community broadly, but here specifically in SOX, is going from the 10 and 40 gig connectivity up to 100 gig directly to Internet 2 was the starting point, but now Georgia Tech, Tennessee, UAB, Vanderbilt, and ESNet and Oak Ridge to start. One of the things I'll make a point here of saying is, for those who aren't familiar with it, it's easy to draw a connection between the NSF, National Science Foundation, CC STAR program and these 100 gig connections. So almost every one of these opportunities basically represents a funding commitment by NSF to make it happen. It certainly wouldn't have happened without NSF. So that process continues, and many of the folks in the Southeast region, of course, have greatly benefited and will continue to benefit from NSF's investment in the connectivity to support big science. So just some of the places we peer. There's a wide range of connectivity, both regionally and internationally. Our primary presence REAP facilities is in Atlanta at 55 Marietta Street, and another important part of this service that it's not just about connectivity anymore, and we're seeing this more and more in the data story and the services, additional services, hosting caching services. In this case, two of our biggest data traffic sources, if you will, are the Netflix and Akamai caching servers that we host in Atlanta, and we have direct peering with Google, Apple, and Netflix. And of course, that's a big part of where the R&E community traffic goes and comes from. So, important part of support. So that's kind of the overview of SOX. I want to switch gears and talk a little bit about some of the research activities that SOX is directly involved in, and working with the member institutions and on funding that we've received directly in support of SOX efforts. The first is routing security, then software-defined networking, and then wrap up with smart cities. And I know there's lots of interest in the smart cities as a direction, research direction, and funding opportunities there. So, routing security, and this is it in a nutshell, right? It's just too easy to lie on the internet, and the famous New Yorker cartoon of "On the internet, nobody knows you're a dog." Unfortunately, it's also true that on the internet, nobody knows you're not Google or whoever else you want to be, right?
What kind of dog?
And there's some part of this comes from some fairly well documented and famous stories over the last decade, really, of attacks on the routing infrastructure that focus on vulnerabilities and weaknesses in BGP. Sharon Goldberg, one of the leading researchers and advocates for helping to fix this problem, explains it best in some of her scenarios. So I use her examples here. But basically, this is about taking advantage of the longer prefix matching that IPv4 wants to do when doing routing, and the fact that in this case an attacker can effectively take someone offline or steal the traffic or what have you simply by advertising a shorter route to your web server. And so, you know, not a new problem. The community's been working on this for a long time. The solutions du jour, if you will, the state of the art is RPKI, or Research Public Key Infrastructure, and BGP-SEC. It's really a two-stepped, two-pronged approach to addressing the issue, and RPKI is the precursor, right? So the first step, if you will, is we need to get RPKI deployed, and then we can work on BGP-SEC. The efforts, so what we're about today really is, so let's get step one done. In order to do that, there are two key things that need to happen. First, the people that hold an address, in this case, let's say universities that have address plus space allocated, basically need to take the legal and technical step of asserting their ownership of their addresses. So in RPKI speak, this is creating ROAs, and I'm not going to try to go into all the gory detail here. I'm trying to sort of summarize it at the highest level, and certainly welcome follow-up and questions later and later today and in the future. But anyway, so the address holders have to do a step which is largely a legal and think of it as a legal document that asserts, hey, I own these addresses. And then the other step is the parallel step is that network operators need to actually start looking for this stuff to turn it on in their routers and start actually checking, hey, is the person advertising this route, are they the valid owner of this route or of this address space? Both are ultimately required, but these things really are two different things, and really what we're promoting, we're trying to get the community to understand, as well as some efforts that the Internet 2 security community is taking now. Really is that, both of these things are doable. We understand how to move forward, and we're trying to work with the community and to get this going. So unfortunately, nothing's without challenges. Why hasn't this already been done? Well, there's some legal stuff that has to happen for address holders. There are some basically issues especially with liability and indemnification about getting these legal documents essentially processed. But then for the network operator stuff, it's about working with the router vendors to actually and get some experience actually operating this and figuring out what the impact is. To the research effort, this is what we've been working on. NSF has funded us and SOX and the SOX community to basically work through this and try to get some movement on deployment and help people document and how to move this forward. So basically, we have some funding today. We have some resources available to I say to the SOX community, but I'll say to the entire South Big Data Hub community, whether you're a SOX member or not, we're sort of ready and able and have both time and even some equipment to help people that want to explore this and deploy it. We actually did a sort of a proof of concept test of all of this by building it out on a Genie on the Genie infrastructure as a test case, simulating the entire BGP deployment. That's what that's depicting. But anyway, to sort of wrap up the RPKI part of this, we have resources available. We have the support of NSF to help spread this out and get it moving, and we certainly would take anybody that's interested in talking more about this. We are would welcome the chance. So on to the software-defined everything side of the work. We've all been, obviously SDN is a big part of the research efforts in networking in the last several years, and SOX has played a big role in that, especially through the Genie project over the years, and we support multiple Genie Racks. I know we've talked a little bit before on this call and in this community about Genie, but just to remind everyone that there is this fairly significant infrastructure available for with compute, storage, and networking to support the projects of this community, and so we should certainly think of that. And there are multiple Genie Racks deployed within the Southeast that are available. I know they're at Rincy as well, and so we should definitely be, continuing to remind people of that resource in the community. So the software-defined exchange is the kind of the most recent big activity. There's a lot of definition of what that means. For us, it really is a little bit of an all of the above, and the different projects that we've taken on, and there are, and we're of course not the only ones working on this. There are Genie efforts with Joe Mambretti at Starlight, and Tom Lehman working at Max as well, and we're really all working together on similar solutions here, and so don't think of this as competition. Think of it as sort of different lenses to view many of the same ideas. For those who this is a huge resource that I encourage people to take a look at if you're not familiar with it, as part of the NSF Looking Beyond the Internet series last year. One of the workshops was on software-defined infrastructure and exchanges, and I encourage folks to check out this report to learn more about SDX and SDN, software-defined infrastructure, and how it relates to the research agendas. Specifically, just a couple more things to then I'll wrap up. We have a NSF-funded SDX project joint with Florida International and the Amlight folks, Julio Ibarra and Heidi Morgan there, and then Cass and Sean working here with us to build an international SDX. Our science driver for this project is the new telescope being built in Chile, the LSST, and when we talk about big data, this is going to be some big data. 6.5 gigabyte images basically that need to be transmitted within 5 seconds, and an image created every 17 seconds, and with a goal of getting it delivered in 5 seconds. You don't have to read all the words. It's a big telescope, And it's going to be down here, and we got to figure out how to get the data back up to to all the researchers around the world that want to interact with it, and control it. It's not just a one-way pipe, but people want to be able to control. With most scientific instrument projects, we're talking about being able to make adjustments in real time so that you don't waste your time, the precious time that you have using the instrument. The SDX part of this is basically building a international software-defined exchange that includes these three sites to be then connected to the rest of the world, if you will. But from a research side, what we're looking at, okay, how are we going to leverage SDN across multiple management domains? So to us, at the end of the day, what makes the software-defined exchange interesting versus other SDN projects is we have to deal with the fact that this isn't one network operated by one entity. It's international. There's multiple parties, multiple players. We have to deal with technical interfacing, but we also have to deal with policy and legal and the business agreements that it's going to take to make this all work, and that's what makes the exchange interesting. From there, the research buzzword of 2016 and going into 2017, of course, one of the biggest topics is around the smart cities work, and we've been very active in that, not just in Atlanta and in the region, but internationally as well, and participating in things like the NIST Smart Cities Global City Teams Challenge, as well as the US Ignite efforts. And we just had a paper accepted actually to take our SDX, talking about what we call the Metro SDX, which is taking the SDX work and applying it to the smart city. And this issue of that I talked about before with when we're talking about peering between exchanges, and the fact that it's multiple stakeholders and multiple business relationships. The smart city space is full of those kinds of issues, and so many of the same ideas and solutions apply there. So with that, thank you all for your time, and happy to take questions, but also very happy. Please promote us, myself, and SOX as a resource. Very often, when a proposal goes in or a project gets proposed by one of our member institutions or one of someone working in the South Big Data Hub, what you need often is a letter of support that says yes, SOX, and there are people that can help you make this multi-institution thing real, to make it happen, right? And if that's the role we can play, we're happy to do that. We're happy to participate on projects and help write proposals if appropriate, but we don't have to in order to lend our support. So think of us that way, and certainly use us that way.
That's excellent. Thank you. Folks have questions, those on the phone.
Are you working, this is Mike over at Renzi, are you working too on the, we have the Genie guys downstairs who are running the racks where you can move software around in slices? I don't know if I'm describing it correctly, but that idea of being able to stand up, computational pieces as well as networks to create sort of applications on demand. Is that sort of playing into the architecture for the telescope too?
Yeah, absolutely. So, yeah, I knew there were folks there, and I thank you for the reference because I didn't know how much you guys know about Genie and Genie Racks and the ExoGenie project. Definitely, the Genie Rack effort is one of the things that's influencing what we're doing in the Atlantic Wave, the telescope project. We think it's going to be critical that there are not just you know, data switching and forwarding infrastructure at the exchange, but compute and some amount of storage as well, and that's a part of the story. And certainly the sliceable rack resources that the Genie has led the effort with is a you know, an important part of that story. I will certainly admit that from a so that, you know, that part of it is not nearly as well developed from the point of view of the Atlantic Wave project is a 5-year project, and we're about 18 months into it, and we're very focused on, if you will, the getting the traffic flows in, you know, yeah, part of it, right? But honestly, I don't see how this works ultimately to meet the needs of, you know, I can do the flows if I've only got one customer, right? But the reality is we're going to have, you know, thousands of people wanting to consume various and work with this telescope data, as well as, you know, other instruments, and moving that computation, but also being smart about how that data is distributed. I don't see any way, you know, we don't solve that problem without some other smarts in the network.
Sure. Cool. Okay.
Excellent. Anyone else's questions?